Afternoon, ladies and gentlemen. My name's Andrew Dugdale. I'm the Engineering Director for Mott MacDonald here in Manchester. And I'd like to talk to you this afternoon about something to try and get your energy levels up a little bit after lunch. I want to talk to you about rubber ducks. We've all had them. We've all owned one. Probably got them at home in the bathroom. But the English language is our biggest enemy. P-way engineers in the room. We have a quick show of hands. You all speak the English language. You all know what you mean when you say, bring me a rubber duck to site, don't you? Civil engineers in the room, quick show of hands. When you bring a rubber duck to site, looks a bit more like this. We've got a problem here, guys, haven't we? We're talking a different language. We're saying the same words, saying the same English language, but it means something completely different depending on your point of view. So when we talk about platforms, it's all about the focus. What's our perspective on life? As a civil engineer, this is my point of view. This is my focus, the coper. I don't know my pacer from my pendolino. And the X and Y standard deviation speech we had before lunch, that was way over my head. Take my hat off to you guys, P-way designers. I was struggling to follow some of the maths there, far too complicated. Civil engineering, we like things simple. We like to know where we're going. But we've got to communicate better. This is our problem, I think. CEMs in the room, you'll know how difficult it is to chair IDC meetings. Getting the civil CRE, the design CRE even, and the construction CRE from the same discipline to talk the same language can be difficult sometimes. But the consequences of getting that conversation wrong can be massive. Get it really wrong and we end up with conflict. We take chunks out of the concrete. Probably more likely we'll create difficult access. And for an ageing population, I think as we've just seen from Neil's presentation, this isn't acceptable to us in the railway anymore. We've got to look at ways to improve this. So collectively we've got to get three communities really to communicate better together. We've got to get our civil engineers to understand what the track and the rolling stock communities all want. And we've got to bring that together to get the perfect solution. And that means we've got to define our rubber duck. We've got to talk the same language. And if we can all do that as a community, we've taken the first step of three steps into simple platform design. So the next 10-15 minutes, I'll talk to you about some of the definitions. And I was sweating a minute when Neil started to interpret group standards. But thankfully, he said exactly the same as I'm going to tell you, so no worries there. I'm going to look at compliance and tolerances as well. Does tolerance matter? And maybe break some of the misconceptions in the room. And I'm going to hand over to my colleague Nick Highton, who's going to talk about some of the challenges faced on site. How do we achieve these setting out strings and the tight tolerances to get us to this perfect stepping distance. So the first thing I learned fairly recently, actually talking to some P-way engineers, which way is up? Where is the origin? Where is 0-0? And it comes back to this track design string, the maintained position of the track. Completely in agreement with Neil. This is a single point, it's a theoretical point. It is not where the running edge of your track is measured on site. It's a different thing. And the relationship is from that 0-0 origin to a space somewhere in that 730-915 envelope, somewhere. And that's where a little bit of the grey area starts. I would point out at this point, this is straight and level track. When we get into curvature and cants, things do start to move around a little bit. And the grid system that's shown on here is a 5mm grid. Now, just to put that in perspective, this grey box that you see on here, for those that have got a programme, there's a little grey box on there, which is drawn to real size. For those with a mobile phone with a camera on the back, you've got a cover on it, you've got a gap for that camera, it's about a similar sort of size. So we try to lift this really heavy piece of concrete, coper, and fit it down so that the edge, which is a curve, it hasn't got a sharp edge on it, so the theoretical edge of that corner is somewhere in that box. And it's not very well defined. So our rubber duck is already starting to look a little bit vague. So we've got to get some consistency in the P-way community. A positive dimension being measured on site needs to be vertically up or stiff in your language, not a lift and slew to go. So sometimes I've seen lift and slews to go with a positive number, meaning that the track is actually lower than that not origin. So we start to get confusion. So we've got to overcome that. Then we pass it on to the civil engineer. And what does he try to do? Well, there's this gauging position and a coper design string position that he wants to put in his 3D BIM model. And then there's this construction tolerance. So if I just take a moment just to explain those three elements. The gauging position is the top right-hand corner, as it appears on the screen, the highest, closest point relative to the track that we are going to allow a coper to be positioned to enable us to get positive clearance. That's not the same point that the civil engineer will use to position the corner of the coping stone in his 3D BIM model. So he'll want a design string position which is in the centre of a construction tolerance. So on here, the sort of square in the middle there is plus or minus 5mm tolerance, which most contractors tell us they can achieve. But actually, we've got a lot more space than plus or minus 5mm to give them, because they can end up anywhere in the blue box. So we don't need to restrict ourselves to that plus or minus 5mm. We can use more. And with Neil's new standard coming in a couple of weeks, we can go a little bit higher still. But that gauging position still needs to be the top right-hand corner of the box that you're going to allow the contractor to actually place the coper. So we've got to get the civil engineer and the P-way engineer to agree this green line relationship from the maintained position of track to the gauging position. So if that's step 2, getting that agreement in place. Finally, when we look at the tolerance of the track, we've got a lot of conflicting ideas and thoughts around this. Where should the track actually go? What is low track fixity? Should I turn on high track fixity in my clear route? If my track ends up slightly away from that maintained position, the ideal design string, have I got to go and do all my gauging again? There's a simple answer, and as long as your track that you physically build on site is anywhere within this grey box, I think is it appearing on the screen here. If you've done your gauging analysis with low track fixity switched on in clear route, you've demonstrated that for that gauging position that you've agreed with the civil engineer, you have got a positive clearance. At that point, you could, if you wished, walk away. You've achieved compliance. But there's another standard, because we don't like just group standards, do we? We like to confuse it. We like to overlay this with a Network Rail Company standard as well. And surprise, surprise, they don't match. So the Network Rail installation tolerance is this yellow zone. So if you go to the bottom of your track installation tolerance, you've gone outside your guarantee of being gauge clear. So as a P-way engineer, you need to be a little bit smart about this, and really you need to start to think about this sweet spot, the green zone in the middle there. So when you're doing your design drawings through a platform, the construction tolerance that you're putting on your track through that platform needs to be a bit closer defined. Now, a really simple rule of thumb is plus or minus 10mm. You know, for those of you that operate tampers and run tampers, all the feedback I've heard in recent months is that plus or minus 10mm is absolutely achievable. And as long as the track is then maintained within plus or minus 10mm of that theoretical centre point, that design line, then you've got a perfectly compliant design. And I think the presentation before lunch, actually, talking about the standard deviation, if we had throughout the network a 3D geometry for every track string, not only would it help us understand this a lot better, but it may help with some of those standard deviation issues that we've been talked about as well. So that's my third simple step. Ensure we get the track tolerance clearly defined. So just to summarise then, first step to success, document your rubber ducks, get them clearly defined and get everyone agreeing, talking the same language. Secondly, make sure that your gauging engineer, your civil engineer, your track engineers all agree where your gauging position is. It's that highest, closest corner of where you're going to permit the coper to be. And the higher and closer that point can be, the more construction tolerance you're giving to your contractor. So that's a good thing. And then finally, in terms of track, make sure that you're defining your track installation tolerance. Plus or minus 10 mil, good rule of thumb to start with. If you need to go tighter than that. So that's it from me. Thank you. I'll hand over to Nick to talk to you about construction.